In this lesson, we're going to take our ideas of data and how to manage data and collect data and start actually displaying data. What can we do to see what we found? So some quick reminders to get started here. We haven't done this stuff in a little bit. Hey, discrete data, things that you count. So number of people in the room, hey, number of people in your family, the number of coins in your pocket, things you can count on your fingers. Continuous, things that you measure. Hey, how tall are you? How much do you weigh? How long did you watch TV for last night? And then categorical, non-numerical data. The color of people's hair, things like that. The size of the clothes you're wearing, small, medium, large. A quick example here. Can you figure out which of these are discrete? Okay, so speeds of cars traveling along a road. Well, if we're talking about speed, we're probably measuring that in kilometers per hour. Okay, numbers of members in your family. That's one of the examples we just used. That's obviously a discrete thing because you count that. The maximum daily temperature. How warm was it yesterday? It was minus 12 degrees Celsius. I measured that. I have units. I can tell that. And heights of people in a class measured to the nearest centimeter. Okay, now this is a tricky one. This one we're measuring for sure because heights. However, when we round something to the nearest centimeter, we're actually changing it to a discrete thing. And we're counting the number of centimeters. So the fact that we've said we're rounding it makes this discrete. Okay, so I want to point that out when we're doing the math for this entire unit. I'm often going to give you nice whole numbers, but maybe those were continuous things I just made easier, or were they continuous things that I actually rounded? Okay, if we're rounding, we're going to call that discrete. So to make our data more manageable, to analyze things, we often want to summarize it. Okay, and then we often want to put that into a graph form. So there's some graphs we should be familiar with. The first one's called a dot plot. Each dot is each individual piece of data. So maybe this is how much time you spent doing homework yesterday, or how many days you did homework last week. How about that? Okay, so there's some people did 3 days of homework, some people did 4 days of homework, a whole bunch of people did 5 days of homework. The occasional person did homework every single day last week, just one person. Okay, that's one kind of graph. A second graph we're probably familiar with would be a column graph. So the height of each bar represents the frequencies. So how many peas are in a pod? Well, there's two peas in each of those pods. There were 3 peas in each of these pods. That happened, I don't know, 11 times. There were 6 peas that happened a whole lot of times, and that happened, I don't know, 51 times maybe. And you're estimating off your graph, right? 51 about that. Okay, so we can figure out how often something occurs. Okay. The basic starting point for graphing is not the graph itself. We usually need to organize our data first. Okay. And we usually organize it into intervals. We call those classes. Okay. Our intervals don't have to be numbers. They can be categorical. They could be numbers and be discrete things, like the peas in a pod, or they could be an interval. We use this for continuous data, which includes a number of different things. We often will go through and make our tallies like we did back in elementary school. And there's 1, 2, 3, 4 of those, and there's 1, 2 of those. But more importantly for us is how often that thing occurs. When we talk about how often something occurs, we call that our frequency. And we're going to use that word a lot, frequency. Usually when we make a graph, we start with the table first. We just organize it. We take our raw data and we sort it out a little bit. And then we choose our graph. Our graph might be a dot plot, or it might be a column graph, or it might be something else. It could be a circle graph, a pie chart. It could be all kinds of different things, a pictogram. Okay? But we usually want to start with our table first. It helps organize things. Once we've made our graph, okay, we often want to talk about the shape of that data. And in this unit, we're going to talk about frequency diagrams. So remember my idea back here with this table is we're making frequencies. When I graph this, it creates a table with frequencies. And these are also frequencies too, actually, if you think about it. Well, when you take those frequency graphs and you put a smooth curve over top of them. Now, it doesn't have to actually be drawn on the graph. It's imaginary. But when you put the curve on the graph, you often come across some patterns, if you will. Okay, so pattern number one is a symmetrical shape. Okay, most of my data is in the middle. Think of this as a bar graph here, okay? And it's pretty symmetrical. It may not be perfect. Maybe it's a little bit bigger on one side than the other. Okay, but if you get that shape, we call that symmetrical. You might also come across one where the hump, if you will, is moved to the left. Okay? If you're thinking about this one, most of my data is on the left side. I'm missing kind of the stuff on the right side, the positive side, if you will. It's really small over here on this section. So we call that positively skewed. The positive side has been stretched. And the other version, obviously, is negatively skewed. Okay? I've got lots of things on the right-hand side, but very little on the left-hand side, the negative side. If we go back to our graphs for a second back here, think of these as having an imaginary, or in my case I can draw it, curve over top of them. The curve goes like this. Well, that shape, it's not perfect, but it looks pretty symmetrical. Okay, it's pretty symmetrical. If I look at the next one, the column graph, if I were to graph this one, okay, it's not symmetrical, though. I'll take that apart. Okay, the left-hand side has been stretched. This one is negatively skewed. I'm kind of missing the negative part of the graph. Most of my data is on the positive side, the right-hand side. Okay, so that's how we describe how our data is distributed. Okay. There's some other things we want to look at in our graphs. One of the important things is the modal value, the most commonly occurring value or set of values, class of values. So if we're talking about modal value, it's a number. If we're talking about modal class, it would be an interval. Again, we go back to our graphs back here. Our modal class, or modal value, I should say, is 5. It was the most commonly occurring thing. Our modal value for p's was 51. It occurred the most. Okay. And the last thing is outliers. Outliers are our exception to the pattern, the things that don't fit with the rest of this. If I look at this graph right here, all my data is sort of right here. It's kind of symmetrical, except for this one. That one's way far away from everything else. That piece of data is an outlier. Hey, maybe this is the number of hours of sleep you got last night. 2 hours, 3 hours, 4 hours, so on. Well, one person got 13. They're an outlier. They went to bed real early, right? They don't fit with the rest of the pattern. So we're going to look at an example, just one today. We're going to try this. We're going to put all this stuff together just to get some basic ideas about organizing and displaying data. So we have Arthur. He catches a train from a busy train station. Over the course of 30 days, he counts the number of people waiting at the station when the train arrives. So I want to do some things. I want to construct a tally and frequency table for this data using, and then tell us the intervals here, 0 to 9. So I need to do interval. I need my tally. That's my check marks. And my frequency. They told me to use 0 to 9, 10 to 19, 20 to 29, 30 to 39. And I know when to stop when I get to the highest piece of data. So I actually have to scan through here and see what is the highest piece of data. Looking at this, it looks like 45 is probably the highest one. So I need one more interval, 40 to 49. Okay, got my interval chart. Now I have to go through and actually tally each thing. So I've got a 17, a 25, a 32, a 19, 45. We're going to go through and make all our tallies, okay? You guys can do this part, I'm sure. If you do it right, you should end up with that many, that many, that many, and that many. Or, if you count them as frequencies, 2, 6, 11, 7, and 4. And there's a tally chart. Part B asks us to construct a column graph. So we're going to take our chart and turn it into a graph. So part B, use a ruler if we could. And what do we have down here? This is our number of people, and this is our frequencies. Okay, what were our intervals? We had 0 to 9, 10 to 19, 20 to 29, 30 to 39, and 40 to 49. Okay, we need to pick a scale up the side. The biggest number we have is 11, so I'm going to go by 2. So 2, 4, 6, 8, 10, 12, and then I'll make each bar. So my first bar is a 2. So I've got 2. Put some numbers on here. And then we've got 6. And then we've got 11. And we had a 7 and a 4. Now, I didn't use a ruler. It'd be a good idea if you did. And just so they're a little bit neater. Okay, but there's our chart. That way the bars are the same size too. Okay, let's answer some questions. On how many days were there less than 10 people at the station? I have two options of doing this. I can look at my graph. That would be these people, and read off the graph. Or, sometimes hard to read off graphs, we like the table. Less than 10 people, that happened twice. What percentage of days were there at least 30? Well, that would include both of these. So there's 11 of the days. How many days were there altogether? And told us in the question there was 30 of them. So 11 out of 30 as a percent. 36.7%. How would you describe the distribution? So if we placed an imaginary curve over this graph, our curve would look like this. So now here's where you have to think about it a little bit. Is this symmetrical? Is this skewed? What do you think? I look at this and I say, I think it's fairly symmetrical. It's not perfect. And in the real world, you rarely get something that's perfect. But this graph kind of looks the same on both sides. Now look at the numbers. Obviously, my first bar is smaller than my last bar, but they're pretty close together, right? All right, what else do we have? What is the modal class? The modal class is the most commonly occurring class. In other words, the biggest bar or the biggest number in our table. Right, we know that's 20 to 29. Okay, and then part G. Are there any outliers? Well, look at my data. They're all pretty close together. There's nothing different from everything else. So I would say no. Everything's pretty close together. Okay, so that's a brief introduction to some organizing and displaying of data. Okay, it's kind of the most basic thing we can do with it. Things we've seen before, dot plots or column graphs. The only new thing is these ideas of modal, outliers, and distributions. The homework today is a handout on the website there. You can print it off, try it. The answers are there. And if you're stuck, come see me.